Aloha! In this problem, we're asked to find a formula for the surface tension, and we're told that there's a ring of metal that's being lifted up slightly so that there's a surface tension on the water that it's resting in. So I've drawn some blue here to be like the water, both inside and outside the ring. So this is something you kind of visualize the water kind of dipping down in the center, like a concave surface, and then on the sides of the ring as well. And we're told that there's a force F pulling upward. And we know, just looking in chapter 10, there's a formula from experiment that gamma, the surface tension, is defined as the force per unit length that's acting in a direction perpendicular to this surface of this fluid. And we know that really the length that we're considering here is the circumference of this circular ring. So we have that L is 2 pi r, because that radius r and the force are what we need to write gamma in terms of. And we also know that this force is really opposing to the surface tension acting on both sides of the ring. So this force per unit length has to oppose twice times gamma. So we have that gamma is F over 2L, where L is the length of the ring, is the circumference, 2 pi r. So that's our formula. This is part A, where we wanted to find gamma in terms of the force and the radius. And part B gives us some information. We're told that this is happening at a temperature of 30 degrees Celsius. That turns out to be a piece of information we don't really need to use in calculations. We're told that the force pulling up on this ring is 6.20 times 10 to the minus 3 newtons. The radius of the ring is 2.9 centimeters. And we're asked to find gamma. So we can just use the formula we just thought about over here, and this is part A. So we're basically just plugging in these numbers, and we don't need to consider the temperature, even though they tell us that. So we just plug in these numbers into the equation, just making sure that we convert to meters here. So you have an answer in terms of Newton per meter. Now you should get 1.7 times 10 to the minus 2 newtons per meter for part B.